So for the demo part today, we're going to be using a K6 load generator. It's going to be sending traffic to a Node.js application that I've got running in ECS. And that system under test is going to make calls to three different services: an inventory API service, a pricing API service, and a catalog API service. And we're going to monitor this using Grafana, and we're going to look at some dashboards that are looking at the performance or the call rates of to the WireMock Cloud Mock APIs. And we're going to demonstrate these types of these capabilities. I'm going to kick off this K6 load test here. And this is going to ramp up for about 5 minutes to get us to our 100 VUs running at steady state. I'll come over into our mock API. This is the one we're hitting, our checkout-demo WireMock API piece. If I come into our request log, we can see lots of transactions are happening here. And as I mentioned, right now we're operating with no delay on our responses. So if we come back and look over at our Grafana dashboard here, we can see, okay, now we've got our information coming in is live now for the last 15 minutes. Let's start to affect this and start to put some real world response times. So let's come into our pricing API. And let's first come down and go about this one way. Let's go into the delay here and just set a fixed delay of 500 milliseconds on our pricing calls. And with the quick change there, we can come back over into any one of our dashboards that we're using to monitor our performance. And we should start to see, some changes in our response profile here. Now we start to see that delayed reaction, right, of our monitoring. Now seeing that, the checkout call is taking about 500 milliseconds. And in fact, we're starting to get an error here. We've got a 502 coming from our checkout process. So we can see, okay, we're pretty much steady state here. We've added that 500 millisecond response time. Let's see what happens if pricing starts to struggle a little bit and pricing starts to go to a 1 second or 1000 millisecond response time. And again, it's probably no surprise what's going to happen here. We'll start to see that our checkout times start to increase. We can also see something interesting here in our purple piece, that our request rate has actually fallen down. So while we were up to close to 800 requests per second before we started injecting real world response times, now we're coming down to about 157 is where we're averaging out here. Now, we're not getting any more errors, right? So far, what we're seeing is, hey, our tuning of our system here, our retry logic, our timeout logic seems to be pretty good so far. But I'd argue we're still not overly realistic as to our response time. So let's change that. Let's do this in one fell swoop using the chaos module. In the chaos module, we can come here and say, well, let's go ahead and put some random uniform delays across all of our API calls. In production, we typically see that calls in the past to these three APIs, are somewhere between, let's say, 50 milliseconds and 250 milliseconds. So I can come down, click this save here. And now that we're closer to a, realistic performance profile, we know we're good at steady state. We played around with one service, starts to have some hiccups. Now we're just focusing on, hey, let's get to steady state with production level response times. Let's now inject a little bit of chaos, right? Because as we said, we all know every once in a while we get those random 501s or 4xx's. So I'm going to come into the chaos module here. I'm going to say maybe just 1% of the time our upstreams are going to produce a 501. And I'll go ahead and I'll tick on chaos here. I'm going to leave our production level response times because we want to lock in on those and keep those constant. Now let's introduce those random errors that happen for no good reason, either from our third-party APIs or our internal APIs, and see again, with our retry logic, with our back-off logic, with our timeout logic, how can I expect my service, my checkout service, to behave under this real-world scenario now? So again, now that we've changed this, we've started injecting some of those 501 errors. We can see that we're starting to get some, more failures here. So we can see, we've got a 503 that came back, even though there's a count going up to 1. This is indicative, right, of maybe hitting too many errors in a row, right? One service, even though it's got retry logic, hit 3 errors in a row. and that's what we tune to be a complete failure. So we can see that checkout is throwing that 503 ultimately here. But again, we're going to take a look at our request rate and our response times. And even though that we're now injecting, some of these errors, we can see that we're still in a really good place, right? We're still handling roughly, now we starting to see it go down a little bit here. If I can get this to come over here, we're still handling about 300 requests per second. And as far as the response times, we're still pretty good on our response times. We're still pretty steady state. We're locked into a pretty good configuration set here, I would argue, showing during this one particular run. So let's say that on our inventory service that we want to actually implement some type of rate limit. So I'm going to come here and say inventory is only allowed to handle 90 requests per second. And when I click save here, what's going to happen at this point is if WireMock encounters more than 90 requests per second to this particular inventory stub, then WireMock is going to send back the rate limited error message to our consuming checkout microservice. And that microservice will then, relying on its configuration set and its libraries that are implemented, determine, okay, when should I retry? How many times should I retry before I completely fail the checkout page? So in implementing this particular piece here, we can start to see the performance profile change a little bit more. We're starting to see that checkout process starting to error out a little bit. We see that blip in the radar going up there. We see our response time has now gone up, as when we're rate limited, we have to back off, wait maybe a few milliseconds or whatever we have configured in our application configuration before it can try again up to the maximum number of retries. So we would expect that response time to go up there. So we're just about at our wind down time here. I'm quickly going to back all of these off. So let's go ahead and take our rate limit off. Let's go ahead and save that. Let's come over into our chaos settings here, turn off our chaos, and let's just go ahead and go back to no delay. And we should see a nice healthy recovery, all systems back to normal. And if we had a little bit more time before this would have ramped down, we would start to see our performance profile return back, hopefully, if our system is able to recover from any one of these particular conditions happening. So we can see right now that our response time is really starting to go back down to where we'd expect. Our failure rate is going back down towards 0, and our request rate is ramping back up.